So when we're talking about solving a system of equations like this, if we have two lines, well, the system of equations, if those two lines intersect at a single point, that gives us our solution. But that's only one possible scenario. That's one thing that can happen. Let's talk about the other things that can happen. So if we want to give three different scenarios that can happen when we have two lines, we just saw the first scenario. This is where we have two lines that intersect at a single point. So when this happens, we have exactly one solution. And that solution is at the intersection of the two lines. But if you think about it for a little while, those two lines don't have to intersect. We've already talked about parallel lines. So this is another possible scenario. So points that satisfy the first equation lie on the first line. Points that satisfy the second equation lie on the second line. Points that satisfy the system have to somehow lie on both lines at the same time. But there aren't any such points here. So if we have two parallel lines, then we would have no solutions. The system of equations that resulted in these two parallel lines, or that consisted of the two parallel lines, would have no solutions. But even that's not the entire story. We could have exactly one point of intersection. We could have 0 points of intersection. And if you think about it for a little bit longer, well, what happens if there's more than one point of intersection? If you have two lines that have more than one point of intersection, well, it turns out they end up being overlapping entirely. So in the case where we have overlapping lines, every single point on this line, or lines, is a solution to the system of equations because it lies on both lines. So we would actually say in this case we have infinitely many solutions. All right, so we have a little bit more, we have some vocabulary that's associated with each of these. If we're in a situation where we have at least one point of intersection, so at least one solution to the system of equations, we would describe this system of equations as consistent. So this would be a consistent system. And this over here would also be a consistent system. Which means that this one would be, well, not consistent, so inconsistent. But this labeling right here isn't quite enough to distinguish between the two scenarios where we have exactly one solution or infinitely many solutions. So we classify these a little bit further. We would say in this case, we're talking about the lines, or the slopes of the lines really. These would be dependent equations. And we would say over here, these would be independent. We either have an inconsistent system or a consistent system. If it's consistent, we have to further classify it either dependent equations or independent equations.